So the origin of these air masses in the two conditions. First one is the surface condition, and the second we have the atmospheric conditions. In case of the surface condition, for origin of the air mass, surface must be uniform and homogeneous. Surface must be homogeneous. And uniform. Air masses most importantly originate over the extensive plains or the sea. Plains or sea. In case of the surface, so air mass is originating from the land surfaces are known as the continental air mass. They are dry in nature. If they are origin in the continents, if they are origin from the land surface, they are known as the continental air masses. They are dry in nature, and if the origin of the air masses are from oceans, if the origin is the oceanic surface, so these are known as the maritime air masses. And they most contain moisture. So these are the two different type of the air masses defined on the surface conditions. So the moisture content of the air masses depend upon these two factors, that is the temperature of the ocean or the sea surface and the duration of the stay of the air masses above the ocean surfaces. The second is the atmospheric conditions. How it will affect? It can be stable air mass and it can be unstable. If the air mass is moving over a region causes the stability or the dry condition, then it will be known as the stable air mass. And if it promotes the precipitation, it will be unstable. And precipitation, that is over the low pressure areas, and stable will be at the high pressure areas. Because in case of the low pressure areas, we have the rising air, and in case of the high pressure area we have the sinking air. How does the rising air will create instability? Because in case of the rising air, it will rise up, then it will form the clouds and it will lead to the precipitation, so it will be unstable. And in case of the high pressure area, we have the only sinking air and it will not affect that much, then it will be the stable air masses. Next we have different type of the air masses. We have Now we have the different types of the air masses. So air mass can be classified on the basis of their origin, that is the surface, that is the latitudinal extension of the surface are taken into the account. And we have the continental air mass and the maritime air masses. Continental air mass and maritime air mass. We have two different type of the air masses, continental and the maritime. So on the basis of the latitudinal extent of the air masses, it can be further classified as the tropical or the polar. On the basis of the latitudinal, it can be tropical and it can be polar. So the tropical air masses originate from subtropical high pressure, and their thermal nature is hot. And in case of the polar air masses, they will originate from the polar high pressure belt and they are cold because of the polar origin. And in case of the tropics, we have the hot air masses, warm air masses. So now let us consider, here we have oceans, here we have land, and here we have oceans. Here we have equator, and this, here we have subtropical high pressure belt, and at the poles we have polar high pressure. Here we have an air mass, there are different type of the air masses. Now how we will classify them? So we because of the coriolis forces we have seen on the equator the wind will deflect in the right side, and if the wind will origin from the polar high pressures to the subtropical low pressure, then it will deflect in his right side. That this is the moment of the wind. This air mass is in the polar area and on the oceans, so it will be the maritime polar. This air mass is in the land surface and in the polar areas, so it will be the continent polar. This again in the oceans on the polar region, so it will maritime polar. This will be the maritime tropical. This is the land on the tropicals, so it will be the continental tropics, maritime tropics on the oceans. Similarly, we have in the southern hemisphere. So we have seen that the continental polar air mass will be cold and dry, because origin is of, because it will originate over the continents, so it will be dry. And the second we have the maritime tropical. Maritime tropical will be hot and humid. And we have continental tropics. It will be hot, and because of on the continent it will be dry. And maritime polar. It will be cold and humid. So these are the different type of the air masses we have. Fronts. When two different type of the air masses meet, the boundary zone between them is known as the front. So when the different two air masses will meet, so the boundary zone between them is known as the front. The process of the formation of the front is known as the frontogenesis. So the process through which the fronts will form, that is the because of the convergence or the collision between the two different air masses. So this process is known as the frontogenesis, when the air masses will be formed. And if they will dissipate, and if there is a dissipation of a front, then it will be known as the frontolysis. So we have fronts, when two different air masses meet, it will create front. The boundary zone between them is front. Cold front tends to sink, and warm front tends to rise. We know that the warmer air will rise and the cold air masses will be sink. Similarly, the front will do. So the process of formation of the front is known as frontogenesis, and the front dissipates is known as frontolysis. So we have two different type of the fronts. The stationary front, when two air masses are unable to push each other. So they are the stationary front. So wind will blow parallel to the fronts. Here we have the cold front, and here we have warm front. So in this case, cold front is moving, and here wind front is moving. Here the warm front is moving. These are the two different type of the fronts. So they will not affect anyone. So wind will flow parallel. So this is the stationary front. So it can be result in the warm or the cold front. Second we have cold front. So in case of the cold front, cold air mass is moved towards the warm air mass. Then what will happen? The cold air mass will replace warm air by pushing and dislodging the warmer one. So it will result in the thunderstorms. And the cold air mass is twice as faster than to the warmer air mass. So the cold front will be the form. So as the cold air mass is dense, it remains in the ground, and the cold air mass forcefully uplift the warm and the less dense air mass. So the front is associated with the narrow band of the clouds and the precipitations. So in case of the cold front, example we have when we have the continental polar air mass, that is called polar air mass will be called and denser. Continental air mass will be cold and denser, and even heavy, are more active. So it will be more active, and then it will result the warm air mass will be compelled to rise vertically, and this will form clouds. And since it will compel the warmer air mass to rise vertically, cloud will be the form and intense rainfall will be there. Now the third we have warm air mass, warm front. In case of the warm front, the warm air mass will move toward the cold air mass. So the contact zone between them is warm front. So as the warm air masses will ascend and slope it condensation and cause precipitation. So the warm front will be ascended and it will result in precipitation. So here precipitation will be mild because tropical air mass will be cold and humid, will be hot. Will be hot and humid, is more aggressive and will dominate. So there will be have mild rainfall. Now the last one is occludent front. So occludent front is formed when a cold front overtakes a warm front. When the cold front will overtake warm front. As the cold front moves faster than the warm front, cold fronts have more speed and the warm have less. So as the cold front move faster than the warm front size get reduced and eventually the warm is completely displaced, and ultimately the cold and the warm front merge into the one form of long and the backward swinging front. They will form single front. So this is known as the occludent front. So in case of the occluded front, two different type of the air masses merge and it will form a single front. This is known as the occludent front. Cyclones have spiral motion because of the Coriolis force. It will reflect on the directions. So cyclones, so the cyclones have counterclockwise direction in the northern hemisphere and clockwise direction in the southern hemisphere. So there are two different type of the cyclones. First one is the temperate or extratropical. Cyclone, and second we have the tropical cyclones. First we have temperate cyclones. So temperate cyclones is the one of the most important atmospheric phenomena affecting the weather in the middle latitudes. So these are known as the extratropical cyclones beyond the tropics, or the mid latitude cyclones, or the frontal cyclones. So there are different types of the different names having the tropical cyclones, extratropical cyclones, temperate cyclones, or the frontal cyclones. They are the low pressure system associated with the cold foam and the occluded front. So temperate cyclones are associated with the cold front, warm front, and the third one is the occluded front. In the low pressure areas. Now there are some features of the temperate cyclones. Temperate and the tropical cyclones are on the basis of the origin of the cyclones. Temperate and the tropicals. So temperate cyclones are originate between 30 to 60 degree latitudes. In both hemispheres. And they are formed by the convergence of the contrasting air masses, such as maritime air masses, which is the hot and humid, and the lighter one is the cold and dry and heavy continental polar air masses. So if we have, one is the maritime tropical air mass. Maritime tropical air mass will be hot and humid, and second we have the continental polar air mass. Continental polar air mass will be dry, here we have done continental polar air mass will be cold and dry, so they are the two different air masses, so they will be result in the formation of the cyclone, temperate cyclone. since they are associated with the different type of the fronts. So temperate cyclones cover relatively extensive area as they are originated in the associated with the convergence of the contraction air masses. So when two different type of the air masses will results in the formation of the cyclone, so it will cover the larger area. So the temperate cyclones extend up to a 10-kilometer area from the sea levels. So temperate cyclones emerge by the process of the fronts formation of the two different type of the air masses. Their shape vary from circular, semicircular or elliptical, and the cyclone can stretch over the 500 to 600 kilometers. They can cover area from 500 kilometers to the 600 kilometers. So how these temperate cyclones will form? Now the formation of the temperate cyclones. So two different type of the air masses. We have two air masses. In the subpolar low pressure belt in northern hemisphere. So the cold air mass moves southward and the warm air mass will move northward. So the cold air mass will move southward and the warm air mass will move toward northward. And form a boundary where the winds blow parallel in the opposite direction. In the stage 1 they will this, and in the second stage, so the two different type of the air masses start intruding each other's territory. Now these two different air masses will start intruding into each other's territory. Now the warm air mass will intrude into the area occupied by the cold air, and the cold air will try to introduce the area occupied by the warm air. The cold air mass will try to introduce the area covered by the warm air mass, and the warm air will try to introduce the area covered by the cold. So this is how the wave formation begin. So it will result into the formation of the waves. Formation of the waves will begin and set the stage for the full-fledged cyclonic circulation. In the third stage, after this, now the circulation will start. So the warm air masses further try to introduce the area now the warm air masses further introduce further, and the cold air masses move toward the equator, and cold air masses will move toward the equator. along the cold front. Now the cold front having a greater speed, cold front have high speed. Then the warmer current, so this will result into the sinking of the warm air masses, and the cold front overtakes the warm. So now that cold front will overtakes the warm front. So the two air masses eventually mix across each other. Now there is the mixing of two air masses. When the mixing of the two different type of the air masses, it will result in the occluded front, and this will get eliminated, and eventually the cyclone will dies out. So this is the formation of the temperate cyclones. Next we have tropical cyclones. So tropical cyclones are the violent storms that originate over the oceans in the tropical areas. They will originate in the oceans in the tropical areas. They will not originate in the land surface areas. Why they will not originate? Because they have some preconditions for the formation of the tropical cyclones, that the temperature around the in that area will be around 27 degrees Celsius. That is, the warm oceans must be there. That is the continuous supply of the moisture. Then the tropical cyclones will be formed. So the suitable condition for the formation of the tropical cyclones are in the oceans, in the tropical areas. So they are responsible for the bringing of the large scale of the destruction in the coastal areas. So it will bring destruction lying between the tropics of the Cancer and the Tropic of Capricorns. Between Tropic of Cancer and Tropics of Capricorn. So tropical cyclones will move, the movement of the tropical cyclones will be counterclockwise in the northern hemisphere. Counterclockwise in northern hemisphere and clockwise in the southern hemisphere, because of deflection of the Coriolis force. Coriolis effect is responsible for the deflection in the directions. So in a temperate cyclone, the energy is supplied from the different air masses to sustain the cyclone, and in the last stage we have seen that when the occluded front get eliminated, so the cyclone will die out. So, but in case of the tropical cyclones, they behave like a self-generated heat engine. That is, their origin is thermal. They have the thermal origin by the release of the latent heat of the condensation. So there are some favorable conditions which will require for the tropical cyclones. First we have is the continuous supply of the moisture. So the condition required for the continuous supply of the moisture is there must be continuous supply of the large scale quantity of the moisture. For supplying such amount of the moisture, only ocean surface are suitable. So only oceans can provide the sufficient amount of moisture. So hence the tropical cyclone are developed over the oceans only. Now the second condition is the warm ocean. Now for the supplying of the moisture, the temperature of the ocean must be sufficient high, and that is 27 degree Celsius to provide the continuous moisture. So the temperature will be around the 27 degrees Celsius. The requirement make the cyclones confined between the tropics. So this is the reason that these cyclones will be confined between the tropics only. And the third is the presence of the Coriolis force. So tropical cyclones require the sufficient Coriolis force to achieve the required circular movement in wheeling motions. So this is the one for the major reason why the tropical cyclones do not develop around the equatorial region. So tropical cyclones will not originate on the equator, not on equator. Why it is so? Because at the equator Coriolis force will be 0. Coriolis force is equal to 2 times of velocity into the sine theta. Theta is the angle, and at the equator the angle will be 0 degree and sine 0 will be 0. So 2 times of velocity into the sine 0. Sine 0 is equal to 0. So the Coriolis force at the equator will be 0. So there will be no formation of the cyclones on the equatorial region. And third, the fourth condition favorable for the origin of this tropical cyclone is the presence of the low pressure zone, a weak low pressure zone. Now a weak low pressure is always required to intensify depression and that transform it into a cyclone. Once a low pressure is developed, the rising air gets saturated and release the latent heat of the condensation to intensify the upper air divergence. So it will continuously supply the motion and generation of the latent heat of the condensation sustain and intensify the existing low pressure to form a cyclone. So these are the conditions required for the formation of a tropical cyclones. So how these tropical cyclones will form? We have the favorable condition having the 27 degrees Celsius, that the temperature will be above 27 degrees Celsius, and so the warm air will evaporate from the ocean surface. So the warm air being lighter will rise, and the rising air contains a large amount of the moisture content. Air will be rise having the moisture more. So as the air masses rise, it will cool condensation and form the clouds. Rising air will form the clouds over a large area in the troposphere. So the surrounding air will rushes in, and so the surrounding air will rushes in and rise. Suppose it is the warm ocean. Here we have the warm ocean. When the air will rise, they will form clouds, and again and this process will continuous. They will form more clouds here, and now the surrounding air will rush and sinks into it. Cold air will descend. So this is the cold air, will descend, and there will be high rainfall. This cloud will precipitate. High rainfall will be there, and winds will flow from high speed. So as the rush is in, so this rising column of the air carries the moisture high into the atmosphere. So these clouds eventually become thick and the heavy. So the energy released by the latent heat of the condensation stored in the water vapor, thus providing a cyclone with the more energy. So this will provide the cyclones more energy. So the Coriolis force causes the rising current of the air to the spiral movement of the center from the tropical cyclone. At the stage cyclone matures, the eye of the storm is created. So this is the eye of the cyclone. This is known as the eye of the cyclone, where the cold air will descend. So this is the formation of the cold tropical cyclones. So there are the different names of the tropical cyclones depending on the areas. Tropical cyclones, and temperate cyclone. First we have tropical cyclones are limited to the smaller areas as compared to the temperate cyclones and form within the Tropic of Cancer. Cancer to Tropic of Capricorn. And tropical cyclones are having thermal origin. In case of the temperate cyclones, they are found beyond the tropics, that is beyond the tropics, that is between 35 to 65 degree north and south. So these are known as the extratropical cyclones. So they have the origin from the fronts. Here we have the different type of the air masses. Contrasting air masses. And in case of the tropical cyclone, these cyclones will move from east to west because the deflection is in northern hemisphere. We have the deflection is in the right side, and these cyclones will move from west to east because of the in the southern hemisphere we have deflection in the left, and in the northern hemisphere we have the deflection in the right. So between the tropics, between the tropics, that is between the 30 to 35 degree, that is between 0 to the 35 degree. So the wind will flow from to the east to the west direction. So the direction of the cyclones will be from east to west. And in case of the temperate cyclones, so the wind between the in the temperate areas, that is 35 to 65 degrees latitudes, it will flow from the west to east. So it will have west to east direction. And tropical cyclones will form only on the oceans, and the temperate cyclones will form on both continents and oceans. their speed is more, and they have, as compared to them, less speed. So these are the major differences between the tropical and the temperate cyclones. Tropical cyclones are hard to predict, and temperate cyclones can predict easily. Because they will mostly origin in the oceans only, and they will